Good day everyone, this is Mr. van der Merwe and today we're talking about probability, part 1, introduction and some basic concepts. Probability. So what is probability? It's defined as a measure of likelihood of an event happening. Expressions of probability, we've got a couple of them. Certain means it's 100%, it's definite, it's gonna happen. Death would be an example of that. Very likely 75 to 99%, so there's a much bigger chance of it happening than not. Likely is between 51 and 74. It means there's a bigger chance of it happening than not. Even chance 50%, it can go either way. Unlikely is 25 to 49%, so it's a bigger chance of not happening than actually happening. Very likely is between 1 and 24%, so there's a much bigger chance of it not happening than actually happening. Impossible, 0% chance, it cannot happen. It's like having 3 birthdays in a year or 3 Sundays in a week. If we look at the probability scale, we see that it's broken into fractions, percentage, decimals, and expressions. We just handled the expressions right now. Let's quickly look at the rest. So in fractional form, we have 0, a quarter, a half, 3/4, and a whole. If we convert that to percentage, it's 0, 25, 50, 75, and 100%. Convert that to decimals, you get 0, 0.25, 0.5, 0.75 and 1. Now let's link that up with expressions. So to say something is impossible, you can either say it's 0, 0%, or 0. Very likely is somewhere in between impossible and unlikely. Unlikely sits at 25%, a quarter, or 0.25. Even chance, there's the notation for that, 50% or a half. Likely, 3/4 or 75%. Very likely, somewhere between likely and certain sits at 1 or 100%. These are all similar ways of expressing the same thing. Synonyms, if you like. Great, so let's have a look at some terminology. Picking at random means to choose without bias. In other words, you're not thinking about it, you just choose the first thing that comes to hand. Right, an experiment is an event or a test. It's an action to determine an outcome. So you must do something. The outcome is what you would like to happen, a favorable outcome, and not like to happen, that would be an unfavorable outcome. So possible outcomes is all the events that can happen. These include your favorable and unfavorable outcomes. See, there we add them together. Now, a trial is the act of allowing or preventing an event from happening. Let's look at an example. So a packet of Smarties contains 100 Smarties, 50 blue, 20 pink, 15 green, 10 yellow, and 5 red. You must please choose one without looking in the packet. There's our unbiased clause, which means you are not choosing what you want, but taking one at random. So what's the possibilities of the colors that can be chosen? Blue, pink, green, yellow, and red. That's our possibilities. So what's the possibility of choosing a Smartie? It's certain. If you stick your hand into the bag, you're going to pull out a Smartie. What's the possibility of choosing a Jelly Tot? Well, it's impossible because there are only Smarties in here. Again, notice how we do it in expression, percentage, as well as decimal form or fractional form. Then, a blue Smartie. So how many blue Smarties do we have? 50 out of 100. So that gives us even chance. It's 50%, 0.5, or a half. A green Smartie is 15 out of 100. It's 15 green, there's 100 in total. So it's very unlikely, 15%, 0.15. But wait, here we have 3 over 20. Why? you must always simplify your fraction. So 5 goes into 15 3 times, 5 goes into 100 20 times. A red Smartie, there's 5 of them out of the 100, so it's very unlikely. 5%, 0.05, and 1 out of 20, again simplified. 5 goes into itself once, it goes into 120 times. If we calculate probability, there's two ways in doing this. We can either do an experimental probability or a theoretical probability. Theoretical probability means using a formula to calculate the probability without doing the experiment. So without is the important word here. So the theoretical probability is the number of favorable outcomes divided by the total number of possible outcomes. If we look at experimental probability on the other hand, it involves you actually doing the experiment and using your findings to calculate. So experimental probability will be the number of favorable outcomes out of the total number of trials. In other words, the amount of times that you got what you wanted out of the total number of experiments you conducted. Let's do a little exercise in experimental probability. Flip a coin and record your results by completing the table. So this is just a little tally table I made. There's the flips 1 to 10. Out of those 10 flips, I had 4 heads and 6 tails. So the probability of getting a heads, please note the notation, probability of getting a heads is 4, as I've gotten 4 heads, out of 10 because it's 10 trials. Let's do the same thing with tails. So the probability of getting a tails is 6 out of 10. Great, so number 11 to 20, again it's 10 together, but this time I had 7 heads and I had 3 tails. So the probability of getting heads is 11, because I said the 4 plus the 7 now gives me 11 out of the 20. So what I'd like you to do is to please complete this table going up to 50. So you'll have 5 rows going down, and please continue to complete the probability of getting heads as well as tails, and see more or less the percentage that you get at the end. If we do this theoretically, we calculate the probability of getting a heads and a tails. So the probability of getting a heads is 1 out of 2. 1 meaning the heads option that we want, the favorable outcome, over 2 sides of the coin, which is the possible outcomes. 0.5, 50%, which is an even chance. To do the tails is exactly the same. The probability of getting a tails, there's 1 tail out of 2 sides of the coin. So 0.5, 50%, even chance again. So is there a correlation between your theoretical and your experimental probability? There should be at this stage. If you conduct your theoretical experiment numerous times, you will see that the results tend towards your theoretical probability. So we can say that theoretical probability is a generalization derived from the experimental probability. Running through a couple of scenarios, we have cards. These are questions that you might encounter just to get the baseline terminology sorted. So there's 52 cards in a deck, excluding the jokers. As a rule, we exclude the jokers, and we call this a standard deck. Then there's 4 suits. Talking about suits, it's the hearts, the clubs, the diamonds, the spades. So it's the different pictures on the cards. Then there's 13 cards in each suit: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So there's 13 clubs, 13 spades, 13 hearts, and 13 diamonds. There's 4 sets of picture cards, a jack, a queen, and a king. Again for each of the suits, so we have clubs, spades, hearts, and diamonds. Looking at a card example, what is the probability of choosing a king from a deck of cards, assuming there are no jokers included? So the probability of getting a king, note the notation, is equal to 4, seeing that there's a king of hearts, spades, clubs, and diamonds, over the total number of cards, which is 52. It gives us a 1 in 13 chance. That is the sign for rounded, because I rounded this answer to 0.08, which is more or less 8%. It's highly unlikely. In an exam, please make sure that you take note to how many decimals you should round. What is the probability of choosing a king of diamonds from a deck of cards with no jokers included? So now we need the probability for a king of diamonds. There is only one of those out of the 52 cards, rounded to 0.02, which is 2%, makes it highly unlikely. What is the probability of not choosing a king from a deck of cards? So the probability of not getting a king is 52 minus the 4 kings, which gives us 48 out of the 52 cards, 12 out of 13, which is more or less 0.92, 92%, which makes it highly likely. Another example or another concept that we use is dice. It's 6-sided cubes numbered 1 to 6. If we look at some examples on those, what is the probability of throwing a 4 when using a dice? So how many 4s do we have? We have 1 4 out of 6, rounded to 0.17, 17%, highly unlikely. What is the probability of throwing an even number? So how many even numbers do we have on a dice? It's 3, namely 2, 4, and 6. So there's 3 of them out of the 6 options, simplified to a half, which gives us 0.5 or 50% even chance. Please remember, always simplify your fractions. What is the probability of not throwing an even number? Also known as an odd number. So what's the probability of getting an odd number? 3 out of 6. There's 3 odd numbers, namely 1, 3, and 5. So it's 3 options out of 6. Simplified to a half, 0.5, 50% even chance. So is it more likely to throw even or an odd number? So now we have to interpret our results. Looking at these two scenarios, both of them has an even chance. So the chances for both are the same, as seen in B and C above. If we look at coins, they have 2 sides, a head, which is a picture, and the tails, which is usually the coat of arms. Some examples on those. What is the probability of getting a heads when tossing a coin? Probability of getting a heads is a half, because there's 1 heads, there's 2 sides of a coin, 0.5, 50% even chance. Then what's the probability of getting a tails? Again, there's 1 tail, 2 sides, 0.5, 50% even chance. Is it more likely to get a heads or a tails? Again, interpretation of our answer, 50, 50, so there's an even chance. There's an equal chance for both. In probability part 2, we'll have a look at what happens when we use more than 1 dice. What if we need to choose between objects more than once? We'll be drawing some trees and tables in math, bit of an art lesson there, so please stay tuned and all the best to you.